So we're back from our lunch break, and now we have got the second part of our lightning talks here on the first day of our competition. Here in this talk, Jelle from Belgium will tell us something about the revolution of identification goods and things about deep learning.
Thanks, Alex, for the introduction, and windy greetings from Belgium as we are about to approach a super big storm here. In the next 15 minutes, I want to share my passion about vision in general and more specific about deep learning. But before I start, just a quick introduction about myself. Jelle Baudouin. I lead Zebra Technologies' global machine vision software division. Which is fantastic. And as you can see, that happened after Zebra Technologies has done an acquisition of Adaptive Vision. And then also I've got something to offer you at the end of my session, but we'll come back to that in just a minute. I will touch briefly on the definition of deep learning with some examples. I want to share the reason why Zebra is stepping into this space, and also some use cases to make it more visual, right? That's a good thing about machine vision and deep learning, is that we talk about images. So before we start, and obviously we'll have some Q&A at the end of my presentation, but just a definition, right, of machine vision and more specific in deep learning. What we do within deep learning is we try to replicate the way that we humans see, and also how we make sense of what we see. Which is maybe a complicated sentence, but when I was born, or when I was growing up, I didn't know exactly what this was. This is a lemon for me, but somebody once taught me that it was a lemon, and that's exactly what we do within deep learning. We have to identify an object, train it, but deep learning is a result of a good training that we've done. So I think this is a very important first definition, to make sure that in order to recognize a lemon, somebody has to explain the system what a lemon looks like, right? So it's yellow. If it's orange, then maybe it's an orange, another lemon. So that's first of all the definition that we need to set. And then also what are we bringing here, Zebra Adaptive Vision? What are we bringing into the market of deep learning, right? So we've got a platform that we've developed in order to enable visual inspection and quality assurance. And it's a platform that we've developed. So the basic principle where we start from is an image. So we don't do a big data processing. We are analyzing images and then take correct actions with that. And the reason why I called it revolution in my title is because Zebra comes from barcoding, right? So barcoding is something that we've invented many years ago. I was not even born yet, where typically we could stick barcode on something, which is still the case, right? Go to your supermarket, go to wherever, everything is surrounded by barcodes to identify it. In the course of the last couple of years, 2D, PDF, that type of barcodes was introduced and generally accepted. And then as a side track, we are also Zebra Technologies is fairly good in RFID, so putting tags on things. But when we entered into the market of vision, obviously it gave us way more opportunities than just putting a barcode on it. And one of the use cases that I will share later on is that if you put a barcode on a product, it will tell you something about the product, but maybe not about the state of the product. So I think in these days, we need to make sure that we've got the right data at the right place in order to make the right decisions. And again, I think that is very important. So the revolution is more in terms of through the eyes of Zebra Technologies, where we see a huge add value by adding vision and deep learning to our solution space. And what's our right to play in this industry, right? So within Zebra Technologies Adaptive Vision, we have been developing machine vision and deep learning algorithms for over 15 years, which is a long time ago. So we started with traditional machine vision, and in the last 6 years, we are more active in the deep learning space. So typically, machine vision reached its sort of boundaries, by rule-based algorithms. I will not go into the detail of that. And then a new technology like the example I just gave about the lemon introduced, which opened up way more use cases than with traditional machine vision. And what we try to do is combine both traditional machine vision and deep learning algorithms in order to create solutions. So what we do is we provide a platform for rapid or a graphical platform for rapid development of your algorithm. So it's a platform that you guys can use to create your own platform where no low-level coding is needed, right? So it's hardware agnostic, so we don't care where the source of data comes from. Again, think about the image that we get. As long as you, with your human eyes, can see what you want to see on that image and the information that you want to get out of the image, then we can handle it with our software. And obviously, we've been dealing around in this industry for a number of years, creating hundreds of use cases across vertical markets, which we then try to combine all together. Um, Now, this is the first example that I've taken, right? So what deep learning? This is maybe not a super clear image, but this is a milk bottle. Typically, again, we scan it. Now we know it's a product X with low fat in this case. The only problem is that we can't see on the barcode is the expiry date because it makes either a good product or a bad product. So, and I've taken, this is just a random example that I've taken from the internet, right? So imagine the consequences that this has if you sell a perishable goods and you drink it as a consumer, and actually you're not supposed to drink it because it was not supposed to be sold to you. That's a compelling case, right? So what we're trying to do now with combining barcode and deep learning, for instance, in this case, OCR reading, is we try to add more value to try to tell retailers, well, this is a bottle or this is a product that cannot longer be sold because of the expiry date. And that I think is a bit of a revolution as well. So it's meaning that we on the edge where a customer takes the bottle. Actually, it should not have been placed in the shelf, but even if it was placed in the shelf, on the edge we can make a decision by telling the customer we don't think that this product is good for you to drink, right? So again, this is something that you will go to your local supermarket, walk around, go to the perishable goods, and probably you see a product which should not be sold to you. So again, this is where deep learning is adding a lot of value. Again, in combination with barcode and OCR, optical character recognition. Um, Use case in retail. Another use case which I've decided to take is, and it's very relevant, right, is in the healthcare space. So again, it might not be 100% clear to you, and neither is to me, but on the left picture, we've got an X-ray of a patient having COVID, and on the right, we've got an X-ray from a patient having pneumonia. So what we have done for this particular case is we have trained a deep neural network to recognize the characteristics between COVID and pneumonia. But that wasn't us that trained it, right? So what we've done is we've asked the doctors and the professors to identify certain characteristics. Think about the orange, right, or the lemon in this case. So what are typical characteristics of COVID and what are typical characteristics of pneumonia? And then we trained the model in the background. So then we can load thousands of images, and then the model itself looks at it as your human brain, but maybe is a bit faster than that and maybe a bit more accurate, because we don't get, our algorithms don't get tired after watching or reviewing a few images. And now we can clearly distinguish between COVID and pneumonia. So again, a use case where deep learning is very applicable with. Again, with traditional machine vision rule-based algorithms, this would not have been possible. So this is groundbreaking, right? And again, it's very compelling, specifically now in the COVID days. Another use case, what we are defining now is, again, well, it's not rocket science, but very compelling. Think about returning parcels. So you order stuff online, probably too much. You have to bring back a parcel to a kiosk or to a postal office. Also there, what we are doing now with you combining various technologies is to be able with two cameras to take a three-dimensional view of a package, and therefore translating that image into data, dimensioning, right? So on the edge of a retailer in a retail store, a customer pops in, put a package on a scale. We got a camera above. We do smart things in the background, and we can show the customer the dimension of its packages. So again, we are combining a bunch of technologies. I'm about to come to the close of my presentation, and what I told you in the beginning, which is a promise that I've made, and which I obviously want to make sure that I deliver on that, is whatever we do within Adaptive Vision and with the platform, this is something that you guys can do, or you community can do as well. So what we want to offer you is, if you go to the website, which is on this screen, Adaptive Vision, and you register yourself, you get a free trial license. Now, I know that a lot of people that are looking live now or will be reviewing this video might have an interest in vision. Again, make use of our offering, register yourself, and then you can start playing around with it yourself and see how valuable this software is. The good thing about the deep learning, or the machine vision and deep learning space that we're currently living in is that we are adding new use cases, right? So again, where before traditional machine vision would have reached the boundaries, now with deep learning, there's way more use cases and vertical markets that we can approach. So again, feel free to register yourself and start playing around with it. And that was my short session regarding the revolution in machine vision and deep learning. And now, obviously, open for questions. Alex, any questions?
You should be able to hear me. Okay.
Now I hear you, Alex.
Yes, now you can hear me. Excellent. Yeah. Very, very well. Thank you very much for your presentation. It was very interesting. And I've got a couple of questions for you that I've written down here. Now, there's obviously not only cameras that we can use to detect things. Have you already thought about, or are you interested in using depth cameras? So adding a third dimension to your platform.
Yeah. So we are we are cooperating with companies that make 3D cameras, which are using our Adaptive Vision software. So yes, 100%. And it's a very good question,
and
right?
For other sensors?
Sorry?
Other sensors as well, or just?
No, actually, like I said, we're hardware agnostic, so we really don't care where that source of data comes from. If it's from a 3D camera or from a sensor, again, as long as on the image that it produces, we can recognize or we can distinguish what we want to get out of it, then we're okay. But we got microscope, we got X-ray, we got cameras, we got even scan engines that we can use.
Okay. Now, obviously this all takes a lot of computing performance. Now, the question for me is, how much performance do you need? Does this, for example, run on a Raspberry Pi, like on a low-powered device, or do I need some form of hardware, like a GPU or something?
Very good question, indeed. Well, it is sort of related to the speed, Alex, what you need in order to process the image. For certain very complex algorithms, when we talk about production lines where we need to check electronic components with a high throughput, obviously then you would need GPU. But we got deep learning applications running on a Raspberry Pi, right? So it really depends on the time that we've got to process the image. On the edge, for instance, if we engage with end users, maybe we get a second, right? We don't need to process the image in 20 milliseconds, but for other applications, we do need it. So we can run it on Raspberry Pi, we can run it on ARM processors, we can run it on i3 processors, but it really depends on the speed and the time that we have.
Okay. Obviously, you are the provider of the general purpose platform, but how far do you cooperate with end customers to implement their vision? Do you give them consulting, or do you do the projects with them, or can can I do this all by myself?
Well, we are a channel-driven organization, so typically we prefer to work with partners, but we got a great support team in Poland sitting, and these are my colleagues that make the feasibility studies. So when we engage with retailers to try to solve a business issue, then we, together with a partner, can make a feasibility study in order to check if the technology and the solution that we provide is good enough for them, and only that retailer or that end user can just can judge on that. So we do offer feasibility studies, and again, our people that support the software are obviously very capable of developing very rapidly some algorithms.
Now you've given us a link where we can have a look at the trial.
Mm-hmm.
Now the question is for me, how skilled do I need to be to get started with this?
Also, good question. Well, if there is a certain affinity with vision, and obviously, as this is a community which has, there is, it's fairly easy to start playing around and sort of build your own algorithm. Once you register, we will also share you links of YouTube videos and a lot of collateral that you can look and teach yourself. So basically, this is typically a platform that doesn't require a lot of training, but you have to start with the basic, and then obviously you can grow from it. So there's a lot of collateral, a lot of help provided in order to build your own first algorithms.
Okay, I think that's it from me, at least. From the chat, I think there's no other questions so far. So thank you very much for the presentation. I found it very interesting, and I hope the other viewers as well. And I think this concludes this lightning talk, and we'll go over to the commentators and to the experts now to have a word.
Thanks,
Thank
Alex.
you very much.